Hi, my name is Eli Boyarsky. I am presenting F-Cardinal conflicts in conflict-based search, a collaboration between Ben-Gurion University and Monash University. So, we all know that in conflict-based search, we start from the set of individually optimal shortest paths for all of the agents, and we search for a set of paths that is conflict-free. So, the question is, which conflict should we resolve first? Should we resolve the green conflict, one of the yellow conflicts, or one of the red conflicts? So we already know it's better to resolve one of the red conflicts first, because they are cardinal, meaning both conflicting agents have no alternative path of the same cost. I'm going to try to convince you that it's best to choose the dark red conflict first. First, notice that this conflict happens after agent Y has already reached its goal, because agent Y is planned to reach its goal at timestep 5, and agent Z is planned to pass through agent Y's goal at timestep 6. Now I need to tell you a bit about heuristics for CBS. The basic heuristic we have for CBS is the size of the minimum vertex cover of the cardinal conflict graph. This is the cardinal conflict graph for the same set of agents as before. Each agent that has a cardinal conflict has a vertex, and vertices have an edge between them if they have a cardinal conflict between them. So the size of the minimum vertex cover for this set of agents is 2, because we have to choose either A or B and agent Y. Now, what would happen if we really resolve the conflict between Y and Z? When we replan agent Y, this is the cardinal conflict graph that we're going to be left with. Because not only is agent Y going to avoid the conflict with agent Z, it's also probably going to be able to avoid the conflict with agent X. When we replan agent Z, this is the cardinal conflict graph that we're going to be left with. Notice the size of the minimum vertex cover in the right child node stays the same. So, in the left child node, the cost for agent Y increased by 2 because it had to leave its goal and then come back. And the heuristic value decreased by 1. So in total, the F value increased by 1. In the right child node, the F value increases by 1 because the G value increased by 1 from the path of Z, and the H value stayed the same. So in total, this is what we call an F-Cardinal conflict. And regular cardinal conflicts we now call G-Cardinal conflicts. F-Cardinal conflicts guarantee that the F value of child nodes will increase. We experimented with 2 versions of CBS. The basic version was a modern implementation of CBS that prioritizes G-Cardinal conflicts. And our new version was the same implementation that now also prioritizes F-Cardinal conflicts before G-Cardinal conflicts. As we can see, on the standard benchmark, for every type of map, more instances were solved by the algorithm that also prioritized F-Cardinal conflicts. Hard instances were instances that required more than half the time limit to solve. And for those hard instances, F-Cardinal conflicts are even more important. As you can see, almost twice the number of agents for every type of map were solved by the algorithm that prioritized F-Cardinal conflicts. In the future, we plan to use the F value of CBS nodes for other techniques, and we plan to also try to identify F-Cardinal conflicts using lookaheads. Thank you.